Hello and welcome to Backer Breaks It Down. In this episode, we're going to be combining functions and actually writing new functions. Okay. So in order to do this, we want to use our algebra of functions. So essentially, we're going to be adding, subtracting, multiplying, and or dividing two functions together. The two functions that we are going to be working with is the function f of x is equal to x plus 1 and g of x is equal to x squared minus 1. Number 9, we want to create a new function. That new function we're going to call h of x. Now, h of x is the combination of f of x plus g of x. So I know that f of x is equal to x plus 1. And I know that g of x is equal to x squared minus 1. So that's the first step, to basically substitute in the actual rule for the function notation. And then we just need to simplify this, perhaps even write it in standard form where the exponents are going down. Okay, and so to simplify this expression, I would want to combine any like terms. And so I have the 1 and the negative 1, so this positive one, this negative one would actually cancel out. So that leaves me with x squared and plus x. So that is the function h of x. That's my new function. In problem 10, we want to create the new function p of x, and p of x is equal to the function g of x divided by f of x. So the first thing I'm going to do is I'm going to make the substitution. So like g of x is x squared minus 1. And then this is over f of x, which is x plus 1. Now, in these division ones, if you can simplify the rational expression that remains, you should do that. And we can simplify this rational expression if there are any common factors that cancel out. So like x squared minus 1, this is known as a difference of two squares. And I can factor a difference of two squares quite easily. X squared minus 1 would become the factor x plus 1 times the factor x minus 1. And this is still over the x plus 1 in the denominator. So notice that we do have common factors. You have the factor x plus 1 on top, and you have the factor x plus 1 on the bottom. So those would cancel out, leaving us with just the x minus 1. And so that's the function p of x. P of x is equal to x minus 1. In number 11, we want to create a new function, j of x. And we're going to do this by going g of x minus 2 times f of x. So the first thing to do is to substitute in the actual rules. So like g of x is equal to x squared minus 1. So x squared minus 1, and then minus 2 times f of x. So I'm going to put f of x in parentheses here. And f of x is x plus 1. I might even bring in a different color. Okay. So that's the first step. Substitute, like actually put the rules in for the function notation. And then the rest is a matter of simplifying. So in order to simplify this, I need to distribute. Now I want to be careful here. Like I actually want to distribute the negative 2, because that will take care of the subtraction and the multiplication all in one step. So I still have the x squared minus 1, and then negative 2 times x is negative 2x, and then negative 2 times 1 is negative 2. So now I am left with combining like terms and writing in standard form. So x squared, I've only got one of those. And then there's like one x term, so minus 2x. And then negative 1 minus 2 would be negative 3. So this would be my new function j of x. So j of x is x squared minus 2x minus 3. In problem 12, I'm creating the function k of x. K of x is created by multiplying f of x and g of x. So step 1, substitute in the rules. So f of x is x plus 1, so x plus 1, and then times g of x. G of x is x squared minus 1. So now I'm ready to simplify. So in order to simplify this, I do need to multiply these two quantities together, and I can do that by foiling. First outside, inside last. So I multiply my first terms and I get x cubed. Multiply my outside terms and I get negative x. My inside terms give me positive x squared, and then my last terms give me negative 1. And then I should combine like terms and or write in standard form. There are no like terms here, so I'll just write it in standard form where the exponents are getting smaller. And that's my new function k of x. One last one to take a look at, and that's m of x is equal to the function f of x squared minus g of x. So step 1 is substitute. So f of x squared, well, f of x is x plus 1, so I want to take that and I want to square it. And then from there, I want to subtract g of x, and g of x is x squared minus 1. Now, I would be careful whenever you are subtracting a quantity. I put the quantity in parentheses like this, right? Now I need to do two things here. I need to FOIL out x plus 1 squared, because it's not x squared plus 1. Like, my advice is write it twice. So x plus 1 times x plus 1, and FOIL it out. All right, so then x squared plus x plus x plus 1. There is a middle term. That's why we can't just distribute the exponent. So this is x squared plus 2x plus 1. Now for the stuff that I have in red, what I would do is I would like distribute like a negative 1 here. Okay, like think of it as negative 1 times x squared minus 1. So we once again are taking care of that subtraction. So negative 1 times x squared is negative x squared, and negative 1 times negative 1 is positive 1. And then it's just a matter of combining like terms, simplifying, writing it in standard form. The x squares cancel out. There's only the x term of 2x, and then 1 plus 1 is 2. So 2x plus 2 is my new function m of x. And so that's how we combine functions. We can combine functions using addition, subtraction, multiplication, and division by performing operations with the algebraic expressions that appear on the right side of the equations. And that's how Becker breaks it down.